Okay, so in order for this power rule to work, we have to have a variable x or y or whatever the variable is raised to a number, and specifically it has to be in the numerator. So a lot of times in order to use the power rule, we're going to have to use our simplification from algebra in order to get it into this form of x to a number in the numerator. So if you remember from intermediate algebra, you had this rule that said that if you have a power and a radical, you could rewrite that as just a base to a power over, or a base to a fraction. So what I like to think about as far as this rule is that everything stays the same except that the denominator becomes the index, or vice versa, the index becomes the denominator. So if you look at, and I changed this on the notes to be the fifth root of x squared, in order to rewrite that, what would happen is everything would stay the same except for this fifth index. So we would still have the x squared, but now this index would become our denominator. So the fifth root of x squared would become x to the 2/5 power. So similarly, if you had, for example, the cube root of x, it's raised understood to the first. Everything is going to stay the same except for this index of 3, and that will become your denominator in the rewritten. So this will be x to the first and then over 3. And the beauty of this is once you use this rule, then you are ready for the power rule, because now you have x to a power, and so you're ready to go through the power rule. All right, so that's our first type of simplification, is with radicals. We are always going to rewrite them so that they are in that form of x to a power. Now, the second simplification that will happen oftentimes is we have an x to a power in the denominator, and we cannot have that. We need x to a number in the numerator. So oftentimes we'll need to move our exponent across the division line so that it can change signs. So here, for example, this 1 over x cubed, you cannot use the power rule on, and I usually power rule. Okay, so because we can't use the power rule because it's x to a power in the denominator, we need to move this x cubed up, and so that will become x to the negative 3. And now once we have x to the negative 3, it's in the numerator, and again, it's ready for the power rule. So just as a quick example, let's go through this question where it says find the derivative of the cube root of x squared. Now again, in this format, we can't use the power rule because we don't have x to a number. So what we do is we rewrite the radical, and that is kind of always our first step, honestly. So rewrite the radical, and the way we rewrite that is that everything stays the same except for that little index. So that index is going to become our denominator. So the index of the radical becomes the denominator. So we'll still have the x squared. Now the index of 3 will be our denominator. Now that is our original function rewritten. We haven't actually taken the derivative. So now we have x to a power in the numerator, so we can take the derivative. So our y prime, by the power rule, we bring down the 2/3. We have x and then 2/3 minus 1, and again the minus 1, we always have to make a quote-unquote magic 1 common denominator, so it's 3 over 3, and that gives us negative 1/3. So our new exponent will be negative 1/3. And of course, there's several different ways that you could rewrite that. You could move it down to the denominator, you could rewrite it in terms of a radical, but this, in my opinion, is perfectly acceptable. Just keep in mind you could also move it down to the denominator. That would be an alternative form. Or you could remove this fraction and write it as 3 cube root of x. So all are perfectly acceptable formats for our derivative.